Hey guys, so today we are going to review for test 1. I know you'll be amazing. Okay, so here we go. Number 1, domain and range. So remember, domain is our x value and range is our y value. Okay, so here we go. So you're going to look at how far to the negative x values this graph goes, and notice it stops here at negative 8. And we touch negative 8, so negative 8. And then we're going to go all the way to here. It stops at positive 8. Because it touches, we're going to put brackets. Now, range. How low or how much of the negative y's do we cover? And we stop right here. And that looks to be about negative 5. And then we're going to go all the way up here to positive 5. Okay. So a nice little contained graph. Okay, so now let's go to number 2. Domain. Now, please take a look on number 2. There's this arrow on the left. So what I'm going to do is just maybe extend it a little bit more so I see it. So does my graph cover all of the negative x values? Now remember, this graph has on the left an arrow that's going down and out. So it will eventually cover all of them. So my domain would be negative infinity. And then does my graph cover all the positive x values? And the answer is no, it stops right here at 3. Okay, range. Does it cover all the negative y values? So remember, we have that arrow, it's going down forever. So yes, it's going to cover all my negative y values. Does it cover all my positive y values? And the answer is no, it stops right here, and that looks to be about 5. And you're done. Yay. Okay, number 3. Let's see. So number 3 is 3x plus 10. We're going to use negative 4, and I need a number less than negative 4. So negative 5. Okay, so you're going to do 3 times negative 4 plus 10 is negative 2. Okay, and 3 times negative 5 plus 10 is negative 5. So we have negative 4, negative 2, and negative 5, negative 5. Has an equal to bar for the negative 4, negative 2, so close dot. Negative 5 is an x. So negative 4, 1, 2. Negative 5, 5. And there you go. Now let me change pens. So now we're going to choose negative 2x. So I remember I have to use negative 4 because it gave us to us, and I need a number bigger than negative 4. We can use negative 1, negative 3. I'm going to use my favorite number, 0. So negative 2 times negative 4 is just 8, and 0 times the negative 2 is 0. So negative 4, 8, 0, 0. So open dot at negative 4, 0, and an x through 0, 0. Negative 4, 8, 0, 0. Okay. And there we go. Remember, your graph should not cross. If they do, my advice is come back here to that first equation and make sure you did pick a number that was less than negative 4. That would be the first place I would look. Okay. So here we go over here. We're going to use this one. So 3x plus 4. I'm going to use negative 3. And let's say a negative 4. So I'm not going to have a lot of room, so I'm going to have to do some of the math in my head. So 3 times negative 3 is negative 9. plus 4 is negative 5. 3 times negative 4 is negative 12. Plus 4 is negative 8. Close dot and an X. So 3 and negative 5. 1, 2, 3. Negative 4, negative 8. Okay. Oops. There you go. Change colors. Okay, so here we go, negative 4, I'm sorry, positive 4. So my equation is going to be 4. So before I even look at my x values, all my y values are going to be 4. So we're going to do negative 3 and negative 1. Neither of them have an equal to, so open dots. So negative 3, 4, negative 1, 4. Okay, like a little dumbbell there. And then this one. So negative 2x. So negative 1 we're going to use again and something bigger. My favorite number still is 0. So this becomes 2 and 0. Closed in an x. So negative 1 and 2, 0, 0. Okay, and there you go for there. Okay, I hope this is helping, guys. Okay, so now number 5, negative 6. So you're going to look back here. Is negative 6 less than or equal to negative 4, between negative 4 and negative 1, or bigger than negative 1? If you said it is less than negative 4, you're correct. And we're going to use that equation. So we're going to plug negative 6 into that x value. So negative 18, so it'll be negative 22. Negative 4. We have two negative 4s, so remember the only way you can tell which equation to use is that equal to bar. So we're going to have to use that negative 1, so we're going to use that first one. So this will be 3 times negative 4 minus 4. So negative 12, negative 16. Negative 1, we're going to have the same situation because we have two negative 1s up here. We're looking for the one where it's equal to, so this would just be negative 2 times negative 1, which is 2. Okay. Okay, yay. And y'all's favorite right here, word problems. Please chill out. You are planning to buy some colorful t-shirt from a catalog. The piecewise function below represents the cost. I'm going to buy 4 shirts. So would I use the first or second equation? And because it's the equal to bar, I'm using the first one. So 14 times 4 plus 7, I believe. So 14 times 4, 63. You forgot to add the 7, yeah. Avery's trying to help. I love Avery. Okay, so that's $63. Now, to buy 5 shirts, it is bigger than 4, so we're going to use the second equation. Now, this one's an interesting little fella. So, be 55 plus 10 is $65. So, notice that only difference between buying 4 shirts and 5 shirts is a $2 difference. And I don't know about you. For $2, I would buy a 5th shirt, even if I have to give it to a person. Oh, Lord. Okay, so 8 shirts. Again, it's still bigger than 4. So we're going to plug it down into the last equation. So 88 plus 10 is $98. Okay, I will see you on the next page. Bye.